I don't have my pens ready. I'm all a mess. Okay, so cosine law is the law that we're going to use when you have two sides in an angle that cannot be set up as a ratio. So no matching set. So we talked about matching sets before. Oh, that kind of is. I'll use it, not red. Right, so our matching set is that angle and that side that are across from each other. So our matching set there. So we're going to use cosine law when we don't have a matching set. You can also use cosine law when you have all three sides and no angle. Okay, so it's just sine law, we need that matching set. Cosine law, we don't have it. Or we have we have all three sides and no angles. Okay, so again, letters, I'm going to use letters, but they don't really matter. They could be X, Y, Z, but we got to be specific on where they are. So if I look at my formula sheet, I have my ambiguous case triangle here. I have my sine law here, just to the right of it, and I have cos here. And I put these little asterisks just to remind myself that it doesn't matter what the letters are, but that they can be moved around. Okay, so here's the law. And what does lowercase mean if I use a lowercase letter? It's a side. And the capital letter? It's the angle, right? So I like to call this one earmuffs. I have so many different little analogies for my formulas. They help me when I'm trying to remember my 800 formulas. So here we go. So you know how we had no matching set? We have no filled in matching set like we need for sine law. But your matching set are going to be your earmuffs. So they're going to be, so one of these you're going to know and one of these you're not going to know. Okay? You're going to know one, but you're not going to know both. And I call them the earmuffs because they're the matching parents. See, they kind of go on the outside, and that's my little analogy. Okay, so you'll know one. But not both. So in sine law, we start off with, we use the matching set because we know both of them, but in cosine law, you don't. All right, here we go. You ready? So let's jump in. So remember that the side that you're solving for has to have a corresponding angle. So if you're solving for the side, you need its angle. And we remember that all triangles, interior angles, so angles inside the triangle, add up to 180. Okay, so solve for the distance between the two aircrafts. So here's aircraft 1 and here's aircraft 2. So my matching set would be at 49 and D. You guys would agree with that because they're across from each other. So angle D is 49, side D is unknown. So these are my earmuffs. These are what, have you guys all seen earmuffs? You know what I'm talking about? They're not very fashionable, but they got a band that goes across them and they cover your ears. So these are going to be what goes on the outside of my formula. And everything else goes on the inside. And it doesn't matter the order that those things happen. So remember that because this is a lowercase letter, that's a side length. Ooh, that's not a leg. Side length. So those both are side lengths, and these here are side lengths. The only angle, that's my only angle in the formula. And this one's a side length as well. Okay, so when I'm looking at this one, so my earmuffs are going to be, I want to solve for D, so that's going to replace my first earmuff. And notice that it's squared. It's kind of like Pythagorean theorem. It's D, but in the formula we have to square it. And that's going to be equal to I don't know, this one plus that one squared, so 72 squared plus 50 squared. It is totally okay in addition if you switch the order of those. And then minus 2 times 72 times 50, oh my goodness, I'm running out of room, times the cosine of the other earmuff, which is 49. So the two things that I want to solve for have to be on the outside of that equation. All right, so now we just got to do the math. These ones are nice. So 72 squared, ooh, that's a big number. D squared is equal to 5,184 plus 2,500 minus, and I get into the habit of doing this. I'm going to multiply these first. Okay, so I need to stress this to you for another example. What operation comes between the 7,200 and the cos 49? Multiply, right? Pretty easy to see. You have to do this math here, order of operations. I know we all know it, but for some reason when cosine law shows up to the show, people lose their BEDMAS order of operations. So you have to do this math before you do any subtracting. Does that make sense to everybody? Okay, so D squared is equal to 5,184 plus 2,500, 7,684 minus, I'm going to go ahead and multiply those. So 7,200 times cos of 49. What am I going to tell you to make sure your calculator's in? Degrees. 23625,009. And again, I have to remind you guys, you do not round until the answer. You got to use all the decimal places. So I got 7,200. No. I have 7,684 minus the 4,723.625009. So D squared is equal to 2,960.374991. Am I done? Do I want D squared? No. What do I want? D. So just like Pythagorean theorem, we're going to square root it. So D is equal to... And so now let's round to two answers. And what are my units of measure for this one? Two answers, two decimal places, sorry. What are my units of measure on this one? Kilometers, yeah. You guys are getting so good at putting your units of measure on, which is awesome. Okay, so knowing that information, which side has the largest angle? Or which angle is the largest angle? I guess which side isn't the correct answer. At aircraft 2, right? We know that aircraft 2 is going to be our biggest angle because this is the biggest side here. Again, that's just a good way to check your answers. I mean, this one's a little bit different because we're not solving for a lot of angles, but it's good to just keep reminding yourself of that. Okay, so I'm flipping the page. Okay, so now this is a little bit different. We're going to solve for an unknown angle. And we're solving for angle A. So that's where I'm solving for. I always like, if it's not indicated on the triangle, I like to put it there just so I can remind myself. So let's talk earmuffs. What do I start my equation with? 18 squared, right? Because we're looking for the side that's across from our known angle. So if you highlight it, if you circle it, if you indicate it, or you just know it, all those things are fine. But so I want to make sure I use the right stuff. So I'm going to have 18 squared equals 30 squared plus 22 squared minus 2 times 30 times 22, sorry, times cos of A. I'm just kind of writing up on those notes there. I don't know why it's so shiny. A little bit better? Can you guys see that okay? Is that okay? Okay. All right. So what's our goal? Our goal is to get cos A by itself. What I would do is I'd work through some numbers first. I would figure out what 18 squared is, which is 324. And 30 squared, oh, I probably could have done that. Oh, I said 4 though. Doesn't that not count for anything? Would have screwed up my whole answer. I told you today I'm having a rough day with numbers. 22 squared is 484. Now I'm going to go ahead and I'm going to do that multiplying again, just like I did before. So that's 1,013.20 cos of A. All right, so I need you to like dig deep into like your order of operations so that you don't lose this. So I'm going to go ahead and combine some like terms. Now, the biggest mistake that people make is that they go ahead and they subtract these two numbers. But that would be wrong in order of operations because these two things are multiplied and that strength is bigger than a subtract. So, let's do some math. How am I going to get cos A by itself? What's going to be my first step? Yeah, so we're going to leave this here, and it's negative, so I probably should have put that in there. We're going to leave this here, and I'm going to minus 1384 from both sides. The negatives don't scare me too much because I got a negative on both sides. So I'm left with, oh, that's a 0, 1,060. Did I do my math right? No, I didn't. Negative. Okay. All right. So you see how easy it is to lose some stuff. Okay. How do I get cos of A by itself now? So now it's that divide, right? So that's why I put that little bracket around it to remind myself that this isn't an add subtract. This is an add, and then there's a division part there. So I'm going to divide by negative 1,320. 1,320 cos A. And a negative divided by a negative is going to be hopefully a positive. So that's 0.803030, and that just keeps repeating. So notice how I drew my line over the two numbers that repeated, okay? So if you're going to use that, make sure that you don't just put it over the 3, you put it over the 30. Okay, so when I want to solve an angle, what do I do in my calculator? We're doing that second function thing, right? So we're going to have cos negative 1 of 0.8030, and that repeats. And that just leaves me with A on that side. And let's round to the nearest whole degree. So these ones aren't hard. Like I find cosine law, I don't know which one I find easier to deal with. I kind of like cosine law better, but I find that the big mistake here is people end up subtracting 1384 and subtract the 1320, and then you're going to get an error in your calculator. Okay, so now we're going to add some word problems into it. And so Friday's lesson is going to be an assignment where I don't tell you whether you have to use sine law or cosine law. You'll have to make that decision on your own, which will be what you'll be doing on the test. So it's good practice. Okay, example number 3. Posts of a hockey goal are 2 meters apart. Okay, sorry guys. This is my bad goal. So we know that's 2 meters. We know that a player attempts a shot from the net at a point 6.5 away. 6.5 meters away. So from here to here, he's 6.5. Notice I didn't make this a right triangle because it doesn't tell me any of that information. Away from one post and 8 meters away from the other post. It kind of looks like an ice cream cone. Tells you where my head's at. Not hockey, but definitely food. Okay, so within what angle must the shot be made in order to score a goal? So what angle am I solving here? Who's shooting? The player. So what angle am I solving for? The one at the player, right? Because we need to know how big this angle is, because he can shoot anywhere in this inside of this triangle, and I mean, I guess if there's no goalie there, then he will hopefully make the shot. Okay, so what are my earmuffs? 2 and A, right? Like, or 2 and theta. Maybe we'll call it theta. We'll get all Greek on us here. We'll put that as theta. Okay, so my earmuffs of this are going to be 2 squared equals 6.5 squared plus 8 squared minus 2. And 2 is in the formula. Like, that is in the formula, so it always has to go there. Sometimes people get confused because they think they know the formula, but then they're not really paying attention to it. All right, I can do 4 in my head. Bless you. And again, I'm going to do that multiplying. Okay, so I'm going to pause here. I'm going to keep going. You're going to keep going. And I'd like you to try to solve for that angle. And the video will keep going, so there'll be a nice awkward silence in the video. Oh dear. Do you guys always write out all the steps when you're doing your practice assignments? Yes? No? Anybody? No. And we'll round to the nearest whole degree. Well, that's dangerous. If we round to the nearest whole degree, is he going to make the shot? Potentially no, but we'll round to the nearest whole degree, assuming that he's still going to make the shot. And I do believe an NHL net is 2 meters from goalpost to goalpost, just in case you're wondering. We had to look it up one year that I did this. There were some hockey players in the room and they were upset with me because I think different levels of hockey, one's 1.8 meters across. This was a bone of contention. Are you guys ready? No? Some are ready, some are still working. I'll give you another few minutes. Remember, you're modeling it from example 2. You're following the same steps. Okay, I'm going to show you. Close your eyes if you don't want to see. Okay? Don't look up. I'm not saying the answer. I'm saying don't look up. Yeah? Good? Keegan, how is it? Good? Okay. You guys good? All right. So that's it. That's all. That's cosine law. I think the tricky part will be deciding, is it sine law or cosine law, and when do I use ambiguous cases? If I've drawn you the picture, you don't do ambiguous cases. If I've given it to you as like possibility, then you have to check for ambiguous cases if it's a sine law.